so hard to stay attached to this world. Feel like gravity, empty heart like scattered. Let's just leave me staggered. Follow me, won't let.
Hi, my name is Sofia Mae Sullano, and today we're going to talk about breadth first search algorithm. So, breadth first search algorithm, or BFS, is a step-by-step that explores tree and graph structures, moving level by level from a root node. It uses a queue to manage nodes, starting with the root node. The algorithm ensures that all nodes at the same level are visited before proceeding to the further levels. By dequeuing the first node, visiting its neighbors, and adding unvisited neighbors to the queue, BFS, or breadth first search algorithm, completely explores the structures. This process repeats until the queue is empty, showing the complete exploration of reachable nodes. Breadth first search algorithm finds common use in different applications, which are finding the shortest path, past existence, level order traversal, cycle detection, and maze and puzzles.
In continuation, breadth first search is characterized by a time complexity of O, open and close parentheses V plus E in both graph and tree traversal, where V representing the number of vertices and E represent the number of edges. So this efficiency makes BFS well suited for exploring connected components within a graph and determining shortest paths in particular scenarios. So BFS systematically explores nodes at the same level before exploring deeper, in comparison to deep first search, which prioritizes exploring one path deeply before backtracking. So BFS is the algorithm of choice for finding the shortest path.
Okay, so GPS navigation application. A GPS navigation simulation demonstrates its effectiveness. The algorithm applied within the context of a navigation application adeptly identifies optimal routes by considering factors like the shortest path and alternate options. In the simulation, BFS proves particularly valuable or unweighted graphs, such as road networks where all roads are treated equally in terms of trip time or distance. The algorithm systematically explores the map, treating junctions as nodes and roads as edges, ensuring comprehensive evaluation of feasible routes. Real-world GPS navigation systems often transcends basic BFS capabilities, incorporating features like real-time data and traffic updates to provide users with dynamic optimal routes based on current conditions, while BFS remains pivotal in navigation simulations. Addressing complexities in real-world scenarios often necessitates the integration of more sophisticated techniques to handle aspects like weighted graphs and real-time data. This is the simulation of our application, the GPS navigation using breadth first search algorithm. So, breadth first search algorithm is commonly or usually used in this application because the role of this algorithm is to find the shortest existing path. GPS navigation using breadth first search algorithm involves finding the shortest path from a starting point to a destination in a systematic and efficient manner. In GPS navigation, the primary goal is to determine the optimal route for a user's current location to a desired destination. So the BFS algorithm is employed as a powerful tool to achieve this by exploring the available path in a systematic way. How this algorithm works, or the breadth first search algorithm, how does it work? So begin at the current location or the starting point, which is the node 0. Create a queue to store potential path, identifying neighboring locations reachable from the current positions. In queue these neighboring locations forming potential path. Explore each path one level at a time, considering all possibilities before moving to the next level. Continue exploring until the destination is reached. All possible paths have been examined. The BFS algorithm guarantees that the first time the destination is encountered, it is via the shortest path. Apply BFS to explore path from the starting point, gradually expanding outward. The algorithm systematically evaluates alternative routes, ensuring it examines the shortest path first. As BFS progresses, it will eventually reach the destination. The algorithm guarantees that the first time the destination is reached, it is via the shortest path. The GPS navigation system then provides the user with the optimized route, minimizing travel time or distance. So as mentioned earlier, the benefits or the advantages of using BFS in GPS navigation system, which is the optimality. BFS ensures the shortest path is identified. Completeness, it explores all possibilities, leaving no potential routes unexamined. Sustainability for navigation. So BFS or breadth first search algorithm is a systematic approach, aligns well with the network structure of roads, making it particularly suitable for GPS navigation. So GPS navigation employing the breadth first search algorithm guarantees an optimal and systematic exploration of potential routes, providing users with efficient and reliable directions to their destinations. Okay, so here's how the demonstration works. So in a navigation context, let's consider a simplified scenario where we want to find the shortest path between 2 points on a road network. We'll use breadth first search algorithm to demonstrate how it efficiently identifies the optimal route. So for example, a scenario, imagine a city represented as graph where intersections are nodes and roads are edges. Each road has a certain distance associated with it. So for example, start BFS from the current location, node A, or as shown in the application, node 0. Create a queue to store potential path. So in queue the neighboring intersections, nodes 1, 2, and 3, connected to the current location, which is the node 0. So BFS explores each of these paths one level at a time. The queue now contains 0 to 1, 0 to 2, and 0 to 3. So for each path in this queue, their neighboring intersections. So the queue will now be 0 to 1, 0 to 2, 0 to 3, then 3 to 4, then 3 to 5. So it continues expanding and exploring all possible paths systematically. So for example, the destination is reached. BFS eventually reaches the destination node, which is the node 21. So the first time node 21 is encountered, it is via the shortest path 0, 3, 14, 16, 17, and 21. So the output to these users is the GPS navigation system outputs the optimal route turn-by-turn directions from 0 to 21, minimizing the distance or travel time. So BFS or breadth first search algorithm explores all potential paths in a systematic manner, ensuring no viable route is left unexamined. This systematic approach is ideal for route optimization as it considers multiple possibilities.
So this is our code of topic breadth first algorithm. So let me introduce myself. I'm Kyle G Labrador. I will be the one to discuss about the flow of this code and the overall flow of this code. So first, let me introduce what I use access modifier. So I use here the public and the private, and also I also import the package, which is the import java util, but I already import the specific name, but actually is you can import like something like this, import java util, and then like this. So this is the shortcut of putting has the asterisk, but me I'm prefer to for use the specific. Like this. So now let's proceed our uh, discussion or the explanation, the flow of this code. So first this has the class, so let's discuss the flow of this every code of class definition and initialization. So first, as you can see, this class has the name of bread first search algo, has the defined with the vertices agilis and visited. So the vertices has the data type of integer. So the purpose of this, the number of the vertices of the graph, and the agilis has the constructor of array list, and has the uh, single dimensional array, and also has the data uh, base type of integer, which it means I can only put a number. So if you put the word and the letter is not allowed. So array list. So another is visited has the data type of boolean, so it means it can be true or false. So before that so what I mean is the true or false is like if the node is already visited, it can be true, and if the node is not visited, it will be false. So so I forgot about the public and private. So public is access modifier, and a private is also the access modifiers. So public, it means can accessible for other class, and the private can accessible only within the declare class itself. So it's like capstone encapsulation is so the purpose of this private array list integer agilis is representing the adjacency list of the graph. So the private boolean purpose is indicating if a vertex has been visited during BFS. So I already mentioned the vertices is the number of the vertices in the graph. Here we have the constructor. I'll also use the for loop here, and I'm also creating empty array list for each vertex in agilis. So here we have the visited in new boolean is from here, also the array vertices from here vertices. So here we have the public and one parameter inside, but this vertices is now in the public. The other here the vertex here is in the private, so only accessible for declare class itself. Is here the vertex here is accessible for other classes. So now next is the constructor. Here we have the name of add age has the two parameter, which is the integer source and the integer destination. So if the destination So what the purpose of this method? So this method is take source and destination vertices as input. It also adds the destination vertex to the list of the source vertex presenting and is between them. So now let's proceed here. What the purpose of this method or this constructor? So this constructor implement the constructor of queue and linked list and has the base type of integer, so it means number only. And then the start, I declare the start here. The start is from here, the parameter of BFS, and then visited is start true. If you want to start, then the BFS will be run. So I use also the while loop and the for loop. So I use this loop for it will be the child node or the parent node hit back to the starting node and proceed to the other destinations. So overall the purpose of this is that purpose of this is uh, take a starting vertex as input. Also it use queue to store unvisited neighbors of visited vertices. So here the queue. So the algorithm of iterates until the queue is empty. It removes the current vertex from the queue, and then it will be print the current vertex, and every for, as you can see, for its neighbor, as you can see here, for its neighbor is not visited. For it, as you can see here, the for the neighbor, for its mean the method of the purpose of the method here is for its neighbor of the current vertex. If the neighbor is not visited, it will be add the neighbor to the queue. So if the neighbor is already visited, it will be marked as a visited or true. So now here the main function. So what the purpose of main function is, main function, I put also the scanner and the constructor of breadth search, and this breadth search is from our Java class name or Java file name. And then so overall the purpose of this is interact with the users. So as you can see here, it will be asked for the number of vertices in the graph and create. I also implement and create a breadth first algo object with the provided number of vertices. So this is what I mean. So the number of vertices is from here, and it will be put here. And then also I use while loop. So is allow to the user to add edges entering source and destination vertices. So vertices, like I said, if you put the inter source, so of course the inter source of the tree graph is 0. Start the parent node of 0 or the node 0, and then if it can be stopped accepting edges when the user enters -1 as the source. So as you can see, if source is equal to -1, so it will be break, or the code the output of the code, it will be stopped if you put the -1. Then after you put the -1, it will be proceed here. The user will ask you what do you want, or what do you like to start your BFS traversal. So for me, if I give you an example, I will start at the 0. So if I start in the 0, so So the child node of 0 is 1, and then the 1 is back to the 0, and then the 0 check if he has the other child node, which is the 2. So the 0 is proceed to the 2, and then the 2 is proceed to back to the 0, and then to the 1, and then 1 is checking if he has the child node, so which is the child node of 1 is 3, and then 4. So something like that is like that that the purpose of while loop. So after asking the starting node, the BF traversal will be run until they reach the end of the destinations or the end of the node, and then all the nodes are already visited. That could be BFS traversal. So it will be print the BFF traversal. So of course the 0, if because you are the starting the 0. So now the overall flow of this code is to initialize the graph and adjacency list. Secondly, add edges based on user input. Third is choose a starting vertex for BFS and explore all neighboring vertices level by level using a queue, and then mark visited vertices to avoid revisiting them, and lastly print the visited vertices in the order they are explored. So that's the flow of this code. So flow and the overall flow of code. So this is our topic, which is the breadth first search algorithm. So like what I before I present before a while ago, before I will present this, so Edwin Magsombol is already discussed about the application of this our topic, which is the breadth first search algorithm. So the application of the suitable application of this is the GPS navigation. So the GPS navigation is usually use the breadth first search algorithm. So through the breadth first search algorithm, your location and your destination will be a guide to find the fastest way or the shortest path. So that's the purpose of the breadth first search algorithm into the GPS navigation. It will be help to us to find the fastest way and the shortest path of our destinations. So that's all.